Hello and welcome to another GED math video. My name is Jillian and I am a GED teacher with Woodford County and Jessamine County Adult Education here in Kentucky. And today we're going to continue on kind of building our skills in the geometry section of the GED test using a little bit of the algebra information that we've learned, just solving basic equations that in that lesson. So we're going to start by looking at this PDF right here. This is a picture of the GED formula sheet. When you sit for the GED math test, you have access to this sheet, and it'll usually be just a sheet of paper just like this. But it's also available on the screen. You'll have a little link up at the top of the screen where you can open up this formula sheet. And this gives you, the whole top half of this is just geometry formulas to use to measure different shapes. We've talked already about how to use these formulas to find the area of different shapes, the perimeter of different shapes. And we haven't talked much about surface area and volume, but we'll get there. Today, I'm going to talk about a specific kind of question that comes up on the GED test where they ask you to find the missing length of a side of a shape when they give you the area or the perimeter or the surface area or volume of a shape. So we're going to use we're going to be dealing with area today. So we're going to be using these top 6 formulas to solve these problems. So this is just a picture of it. We're going to refer back to these formulas, but this is where those formulas come from. And we're going to use these exact same ones to solve our problems on the page. Okay, so let's get a blank screen if I can. How do I get a blank screen? Let's see. There we go. Okay. So we're going to start by thinking about a rectangle. So let's put a rectangle up on the screen. And let's say a question tells us that the side length, one of the sides, the short side of this rectangle is 9.5 feet long. And the question tells us that the area of this rectangle is 138.7 feet squared. So square feet. Okay. And the question wants to know what is the length of this, or the width, sorry, of this rectangle. Okay. So it has a length of 9.5, an area of 138.7. What is the width? Okay. So we solve this problem by starting out with the formula on the formula sheet. So we know that the area for a rectangle is length times width, right? And now we're going to substitute the numbers that we know. So we know that A equals 138.7. So we're going to substitute 138.7 for A. We know the length is 9.5, and we don't know the width, so we'll keep that as a W. Okay, so this up here is our width, our W. Okay, so now we can look at this and kind of see a one-step equation. Once we've substituted all these numbers in for the measurements that we do know, we can see a one-step equation. And we know if we're multiplying over here and we want to get this W by itself, we have to divide out this 9.5, right? So we divide this side by 9.5, and then we go ahead and divide this side by 9.5. We'll just do like this. Okay. We drop down that equal sign, and now we have 9.5 times W divided by 9.5 is just W, and 138.7 divided by 9.5 is 14.6. Okay, so now we know the width of this rectangle is 14.6. And to check ourselves, we can substitute these into the formula and say 9.5 times 14.6. Does it equal 138.7? If it does, then we did it right and we can continue on, okay? And we can also kind of use our common sense. Looking at this rectangle, that looks about right. If we had come out with an answer like 2.1, we know that this side down here is longer than this side just from looking at it. So kind of bring your own common sense to the table as well here to help you check your answers. But for this one, this all makes sense. It adds up in the equation, so we're good to go. Okay, so that's our rectangle, how to find the missing side of a rectangle. Let's move on to a triangle. So I'm going to draw a triangle. It's a little crooked. That's okay. You know what I mean. All right. So for this triangle, let's say we have a length here or a height of 6.8. And we want to know what is the base of this triangle. And we have the area as 19.55. And these are all in centimeters. Okay, so our formula for the triangle is area equals 1/2 times the base times the height. Okay, so we do not have the base, but we do have the height. Okay, and we have the area. So we're going to start substituting. A is 19.55. 1/2 stays the same no matter what. B, we don't know. So I'm just going to put a dot here to make it multiplication since we're kind of mixing things up. And then the H, the height, is 6.8. Okay, so we're going to go ahead and divide both of these values out. Okay, we could simplify this and multiply these together first and then divide it, but either way, it's 2 steps either way. So we'll just do it this way. All right, so we will divide by 1/2 on this side, divide by 1/2 on this side, divided by 1/2, 0.55 divided by 0.5 gives us 39.1. Okay. These two 1/2s times 1/2 divided by 1/2, they cancel each other out. So now on this side, we just have B times 6.8. Okay, we're going to divide each side by 6.8. Over here, 39.1 divided by 6.8 is 5.75. And 6.8 times 6.8 divided by 6.8 cancels itself out. So we end up with just B over here. So our base measurement is 5.75 centimeters. So we've solved our missing side. Okay. All right. Let's move on to one more type of shape that we might see here. I'm going to try and draw one, but man, they always come out looking a little crooked. All right, so here we have a parallelogram. And this parallelogram has a length of, or a base of 27.25, a height that is unknown to us. We don't know how tall it is, but we do know that the area is 313.375. And we'll just say these are all inches. And that's inches squared. Okay? All right. So for this one, a parallelogram, the formula is very simple. It's just the base times the height. So once again, we have our area. So we'll sub that in, 313.375. We know our base, 27.25. We do not know our height. Okay, so 27.25 times H. So once again, we're just going to divide each side by 27.25 to find out what our h is, to get that h all by itself. So these two, once again, cancel each other out. And 313.375 divided by 27.25 gives us 11.5. So this unknown up here, the height, would be 11.5 for this parallelogram. All right, let's look at one more shape. And it's the funkiest of all. Oh, I'm going to try and draw a decent looking circle. Okay, that's not too bad. Could be much worse. All right, so here we have a circle, and the area of this circle is 50.24. We'll say meters. So for a circle, for this circle, the only measurement we know is the area. And the question maybe is asking us, what's the radius of this circle? What is the measurement of the radius, which is the halfway across the circle? What is that measurement? Well, we can look at our circle area, our area formula, which is area equals pi times the radius squared. So let's make our substitutions where we can in here and see where we end up. So we know the area, 50.24. We know pi for the GED test is always 3.14. And that's also on the formula sheet in just the tiniest type ever. They say they want you to use 3.14 for pi on the GED test. So that's what we usually do. So pi is 3.14. We do not know the radius, but we can still put that little r squared. That's fine. So let's see if we can pick apart this problem. So we know right away we have a times 3.14 here, so we can divide that out, 3.14. So we can divide both sides by 3.14. So 50.24 divided by 3.14. 50.24 divided by 3.14. All right, we have this side is 16, and 3.14 divided by 3.14, that cancels out. So we just have r squared here. So if 16 is r squared, we need to do the inverse operation of a square. And I didn't talk about this in my last video, but the inverse operation of a square, the opposite, is a square root. It looks like this. To find the square root of a number is to find out which number you can multiply by itself to equal that number. So the square root of r to the second power is just r, because r times r is r to the second power. So the square root of that is r. The square root of 16 is 4, because 4 times 4 is 16. So then we know the radius of this circle is 4 meters. Okay? All right. I'm going to put up some practice shapes on the screen, and I will write down beside each one kind of the steps I took to do it. So I'll put up the shapes and their measurements, pause the video there, and see if you can work them out yourself. See if you can find the missing sides based on the area and the side lengths that you have, and see if you can do it. If you have trouble, fast forward to the end of the video, see all the answers and the steps I took to get to those answers. Okay? So go ahead and So here are all of our shapes. Each has a missing side. So go ahead and pause the video right here and see if you can work these out. And I will write all the steps down, fast forward to the end, and you will be able to see how I solved them all. Answers, here they are. So you have each answer is inside the shape. I thought that might help. This one I rounded, so it was a longer number, but I rounded it to 7.2. And the other ones I think are all pretty straightforward. This triangle, if you were having trouble, it's because I didn't put the area down. So I put the area over here. You can go ahead and calculate it and see if you end up with 17.3. Otherwise, that is about it. So take a minute, check your answers, make sure you got everything. And if you have any more questions, leave them in the comments. I will also link below some more exercises you can do online if you want to practice this skill a little bit more. And this concept can go across all that first half of the formula sheet for finding a missing side when you have the volume, or finding a missing side when you have the surface area and a few different sides of a shape. So take a look through those. And again, I'll link some practice pages in the description of this video. So I hope you learned something new today. Enjoy finding the missing side lengths when you have the area, and we'll see you next time.